This is problem 2 from the 2010 final exam. So in this problem we have the scenario, title insurance is required on every home loan in Pennsylvania, and they determine the state determines the price of the insurance, and if you refinance within 3 years, you're supposed to be charged a reduced rate. Now there's some people suing because they said more than 50% of homeowners were not offered the reduced rate even though they were eligible. So to test this hypothesis, they select a sample of 300 eligible loan refinances, so N equals 300. And we have 165 loans that were overcharged, so 165 overcharged. And that means that 135 were not. And there we go. And the average size of the overcharge was $350, and the SD was $250. We'll get back to that later. The attorneys, there's not supposed to be an apostrophe there. This was in the exam, but I just wanted to point that out. They claim that the data proves their claim. More than 50% of the homeowners are being overcharged. So we have to do a hypothesis test here, right? Because we have a claim up here. More than 50% are being overcharged. So that is their claim. So to test, how do we test the claim? We set up a null hypothesis, which is not that claim. So the null hypothesis is that exactly 50%. So P equals 50%. And we'll just define P is the percent of people overcharged. So the null hypothesis is that. So since they said more than 50% are being overcharged, the alternative hypothesis is that P is greater than 50%. Right? So we need two things, right? We make some box model, and that box says we have zeros and ones. So under the null, so if the null is true, if H0, this is our box. We have zeros, and we have ones, and we have 50% of each. 50% of each, if the null is true. So what does that tell us? That tells us that the expected number of people out of 300 who will be overcharged, so expected then is 150. Right? Because that's how many we expect to be overcharged if this is true. We also know that the SD of the box, is a half. Where do we get a half? Because that is square root of a half times a half. We have a 0, 1 box, so 50% of each, so that means there's a 50% chance of getting a 0, 50% chance of getting a 1. So the SD of the box is this square root of the product of those two probabilities. Therefore, the SE, of the sum is equal to 1/2 times the square root of 300, because that's the total number of draws. So then, and that's about 8.66. 8.66. So we have our expected. We have our SE of the sum. So now we have to compute a z-score. So we say observed minus expected divided by the SE of the sum is equal to 15, because it's 165, right? 165 minus 150, so it's 15 divided by 0.66, and this is equal to 1.73. So do we reject the null hypothesis, or do we stick with it? Well, I say that we reject. Why do we reject? Let's draw our normal curve over here. So if the null were true, we would expect 150, and we would be out about 1.7. So let's actually make this 0, because it's we want to make it a standard normal, because we've standardized it. So this guy would be around 0. And then we're out here at 1.73. So since the hypothesis test is greater than, we're saying, what is the probability that at least this many people were overcharged? So we're looking only in this tail. Only in this tail. This is z-score, and this is just your y-axis up here. So we're saying, what is the probability that at least we see a z-score at least this big, so at least 165 people are overcharged, and this is in the rejection region. If we look it up on a table, remember that for a one-sided rejection region, probability that z is greater than 1.65 is 0.05, and this is bigger than that, so we reject at the 5% level. And we could also have done this with proportions or percentages instead of counts. All I would have done is divide each of these by 300, because the expected could be turned into a percent, the observed could be turned into a percent, and the SE for the sum could be turned into the SE for the proportion. That's another way to do this. This way we used the counts. In the next part of the video, I will conclude the problem.